So topic for today, how business problems turn into artificial intelligence problems. That is very abstract, I think. But what I want to talk about today is how do we come from a first idea at client side, because I work for a company which is a service provider in the IT field based here in Berlin. Some information will follow. How do we come from a basic idea to a business case, and how do we translate such a business case to a problem which is more an IT problem? So what is the process like? How do we come from the idea over exploration with data? So how do we explore data and then bring this exploration and the results to a mode that we can say we have a system that is used in production, that a client can use or that a company can use, that helps also the end users, which is still very abstract what it is about, but it will become more concrete. So first let's start, what's the company that I work for? It's called the Unbelievable Machine Company, and we sit here in Berlin. We are a full-service IT provider with focus on cloud services and big data, which means we have a hosting infrastructure. We have several data centers in Frankfurt, in Amsterdam, in Berlin, with more than 1,000 square meters, where we host all the different servers, with offices mainly here in Berlin and in Vienna. And what we create is we implement hand-tailored solutions, which is like an agency approach, you can say. So really starting with the idea at client side and implementing software, which could be also, for example, an e-commerce shop. So a company wants to have an e-commerce shop, and our company then starts to do the concepts and starts to think about what does it need to be about, and then we start to implement it and later host it. But mainly today it will be about the topic of big data, what it really means, what we do there, what I do there, what my team is doing there, and what it means when we say that we create data solutions. I want to give you many different insights and some impulses and ideas, several aspects of our work, what we are doing, and especially what artificial intelligence or something like machine learning means, and how it works, that you get a feeling of what big data or data science is about. We have here about 120 experts working in Berlin and Vienna mainly, as said. And so as we do the whole process of software implementation, mainly based on data, we have people from several fields like DevOps, which is kind of system engineering, very traditional system engineering, which means hosting servers and doing everything which is related to that. But also we have data scientists working, classical developers from front end and back end. So we are mainly an IT and a tech company, and which one of our claims is we create big data solutions from idea to cable. So to cable means when we host the system that we implement, we do everything. So also cabling the servers in our data centers. So from the first idea, which is very abstract, over concepts, over data exploration, over development, to hosting these applications in our data centers. And that is another claim, which is more like marketing stuff. But you can say that we built the backbone or the platforms for IoT means the Internet of Things, which is also strongly connected to what we are doing, so that you have things that are connected, that have sensors, that create data, and we build something on top of this data, which can be software as we know it. We use data solutions every day when we think about all the Google systems, all the Google services, or Spotify, or I don't know. Everything is more or less related to data, and I think the talk before was also about big data, so I hope you're a bit familiar to that. About myself, I work as an artist and a data scientist at at the Unbelievable Machine Company. I work there at for 4 days as a data scientist, and the other 3 days I do several projects with friends of mine. I will present you, or I will give you some details about what we are doing there, because it's also strongly related to my job and what I'm doing there as a data scientist. My background is I come from business intelligence world, which means also companies want to use their data more efficient. So if you have, for example, a CRM system, a customer relationship management system, so for example, customer data or any data which is in the company, they want to analyze that. And I did that for some time before I worked at the Unbelievable Machine Company, those days for IBM, and changed to the Unbelievable Machine Company 3 years ago. And I work more on the client side, which means creating these concepts and prototypes. And my goal is to find out, can we solve business problems with internal data from companies or external data, which can be weather data or open data from the web or data from sensors, data from machines. So to find out if there is something in it that you can use for business, because of course it's a business company that I work for. So I told you that I'm not only doing this data science job, but something which is related to that. Here you see 2 projects that I did the last 2 years, which was the Datenmarkt on the one side. I don't know if someone has heard about that. The basic idea was to do a project where we emphasize that our data has a wealth, that it's a currency more or less that we use every day. And the Datenmarkt was a supermarket that we built for 1 week in Hamburg, and which was fully equipped with everything that you need for a supermarket. You see over there was toast bread, and there was dumplings and some products that you could buy for Facebook data. So we had a checkout system, a cashier, where you did not pay with an EC card, but you could use our application that we programmed, which was a tablet, and there you connected via Facebook Connect. And depending on what you bought, it asked you for the data. So for example, the dumplings costed 10 private Facebook messages. And we did a kind of liquidity check, which meant that the system checked if you had the data, if you had the currency, and if yes, the results were printed on a receipt. So on a physical receipt, you saw immediately what you paid with, and the concept was to translate this abstract term of data which we pay every day with, and we don't know who is using it and what is done with it. So to get something immediately for that, something physical, so that it is kind of face-to-face deal, like we use money, but there you use data, and you knew what you paid and you knew what you get for that. So that was the first project about the value of our data. And the second project, which is also strongly related to the job of data science in context of big data, it was about the value of our labor. Because of course when we talk about data, when we talk about artificial intelligence, the job market changes rapidly. It will change rapidly in the next years. I will talk a bit about deep learning, for example, which will change a lot in our industry, I would say. So that especially the mix of deep learning, I will talk about that, what it means, in combination with robotics, will definitely change industries, will change logistics, and we now see it, and it will be definitely more. So what was the Schwarzmarkt about, the second project? The value of labor, what we did is we asked 50 or 60 people from different jobs to paint a glass for 1 hour, and the goal was to paint it black. So in the end, all of them were black. So we had 50, 60 different pieces of black glass. And And what we did afterwards is we sold that as art pieces for the price that the people earn in their normal life. So for example, the advertising agency owner, it cost 300 euros approximately, and there was a student, for example, with a BAföG money for 2.50 euros. And so we had this whole range of different jobs and sold that and did a huge exhibition, and we filmed also the people. So in the end we had 40, 50 close to similar paintings, but they were not exactly similar because you could see the structure, and the people started to paint different things, but in the end it was black. But we filmed it, so you had also the individual videos. So on the one hand, this similar end result, but the unique videos. And there will be a third part, which is a Weltmarkt, hopefully this year, which will be about a mix of this data thing and labor, human versus machine. It will be about the devaluation of ourselves by artificial intelligence. So this first project looked like that. That was a system, and that was a checkout. And this is what the supermarket looked like. Here, for example, the dumplings for some Facebook messages. Oh, it was 5. But in the last day, we did a 50% discount on everything. So the dumplings were just 2 private messages. Okay, today. Not only talking about art, but about business. And this is one thing that we created in our company a few years ago. It is called the data science process model, and it should show how these data science projects, how they work, how is the process, is there a process? Because it's totally new, the term of big data is totally new. All the companies are interested in that. You read everywhere about that. They want to find something in the data. They want to do something and create the biggest business cases and earn as much money as they want. But of course, for these projects, they want to know, is it plannable? Is it a normal project? They want to, they are used to it, that they have something, okay, they know how, for example, an IT project works. But what is about data projects? And this data science process model goes step by step, and you have here some iterations, which is also connected to the IT field, which is now very common that when you do development projects, to work very agile, to be in contact with the client all the time, and not to create a big concept and they pay $1 million and then you do something in which is totally different than the stuff that they wanted, but to be in contact all the time with the client. And this is what we do when we do these projects. How many of you heard about the term, or I think all of you, bullshit, but how many of you would think that you know what big data means? How many of you think that you know that what big data is about? I think I know that. Okay, so I will ask you after the session. And I showed you the data science process model. This is the first part, data. So of course, data is generated all the time, and I think this is the topic of this whole lecture series, not the whole, but it will be about that. But here's some examples. Again, for example, the Google car, of course, it's now about autonomous driving. We read about that also a lot, which creates, in this case, 1 GB, 1 gigabyte of data per second, which is a lot of data. Here, for example, we see the data Barbie, which was created, I think it's not that old, but the basic concept is that this records the voices of the children and they can ask something. The question is sent to a cloud that is interpreted, and then the result goes back, and the Barbie talks to the children, which is we can judge how we think about that. I don't know, but it's interesting that cases like that exist. And for example, this comes from the Internet of Things world. It's Cebit. They won the first prize for an Internet of Things product. It's called Wunderbar Schokoriegel, like the Wunderbar Riegel here. And I find it very strange that they were allowed to use the same name for a chocolate bar. But here you have several sensors, for example, a sound sensor or a light color sensor, and you can just use the chocolate bar, get a piece, and plug it somewhere and create the data. And This data is then also sent to a backend, and then you can analyze it. But what to do with it, it's totally open. So it's kind of building a platform, giving the possibility of creating data, and then what you do with it, it's your choice. So nice product that emphasizes how we will create maybe in future our own personal data, I don't know. That is the science part. It's a paper that was published just a few months ago from the Stanford University, stock market forecasting using machine learning algorithms. Quoting, in this project we propose a new prediction algorithm that exploits a temporal correlation among global stock markets and various financial products to predict the next day's stock trend with the aid of SVM support vector machines. It's an algorithm from machine learning. Numerical results indicate a prediction accuracy of 74% in NASDAQ, and so on. So it's something that many people were and still are interested in doing that. And it's getting closer that these problems are solved. So that is the science that you can do on data that exists. And talking about science, talking about data, I said that I'm a data scientist. That is one quote from Hilary Mason. She was the chief data scientist for Bitly. It was from 2012. Here she said what she thinks what data science is about, what the data scientist is doing. Here are some fields. So a data scientist is not an engineer, but somewhere in between, and not engineering only, but computer science, hacking. Hacking just means doing quick programming work. So you have data and you want to find out something, and then you start to create algorithms. You start to explore the data, which is closely related to statistics. Here she said math, and she was a chief data scientist, and she called herself an awesome nerd. There are other quotes from Twitter, for example, that they say a data scientist is just a statistician with a Mac. But I really think it's something in between, and it's not ready, and we cannot really say what a data scientist is doing. But it's closely related to everything, because you have to be from the computer science world, or you have to know about how to use computers, because you do the computing on the data on machines, for example, on my Mac or on clusters of computer. You have to know about statistics, but of course not about everything. But what she missed out is the artificial intelligence part, machine learning, or better to say deep learning. Now, what is machine learning? This is machine learning. For example, a spam filter that we are using every day. Because what we are doing is we are training the machine. Maybe we are not every day, not all of us are still training the spam filter because it works. And maybe you use a Google account, and in the background it decides what is spam and what is not spam. But on my Mac, I have a client software, Mozilla Thunderbird, and I can say this is spam, this is not spam. So I train the machine. The machine abstracts this information to a mathematical model. And over the time, it decides by itself what is spam and what is not spam. So it's about learning. The machine gets trained and knows after some time what is spam, what is not spam. Another example is face recognition. It works, it's solved. So the machine gets trained with a lot of data, and it gets the information what part of an image is a face. And from that it can learn. But to learn, it needs to abstract the image and build a mathematical model out of that to get the knowledge which part of the image is a face, to be able afterwards, and as more data you have, as more accurate the results will be, it learns over time, and then after some time can decide by itself what is a face and what is no face. Coming closer to business cases for us, where we use machine learning, for example, is when we go to a client, an industry client, and they have machines. Here in Germany, there are many huge industry companies, and these machines often create data, which is often messy data, but they have some sensors plugged to the machines. And what they want to know, for example, is to predict when these machines break down. So you can train with the data that you have a model with the behavior of the machines, and you know based on data, when in the past, or you need to know when in the past there were breakdowns, so that the machine can build a model and find this correlation of, okay, the behavior of the machine and when does it, when there was a breakdown. Still a bit abstract, but I hope you understand, not so much time to go into detail. But here, for example, you see a visualization that we create in such projects when we explore the data, original value and predicted value. So we created a model based on data, and then this model predicted the machine breakdowns over time, and we have the original value, which means we know when it really happened, so that we can see how good is our model working. So how good is the prediction that we created on the model based on data that we trained the system with in comparison to the real values about the real breakdowns. And when this is very close, and here it is very close, you see between yellow and blue there's not such a big difference. You see you can use that afterwards to predict, for example, machine breakdowns. That means for us we are exploring more or less the best features. Features, it's kind of, for example, when we have an image, the machine needs something to understand the image, and that can be, for example, a numerical value for the grayscale. So we see here all the different values which indicate is it light gray or is it dark gray, and later So this mathematical values it uses to learn about this image. And if you feed it with all these, with thousands or hundred thousands of pictures, it can abstract that and create its own model to be later, for example, able to say this is a dog or this is a human, which is currently also more or less solved. So Google is using it and all the other companies are using that, and we also are using that to be able to classify pictures. And this is just an example how such an algorithm works. So it needs, still very abstract, but just the only thing you need to know is to transform such an input to a kind of mathematical thing, which is values. And this wouldn't be the best feature for such a model, but it would be some way of how you could, how this machine could interpret images. In the end, it's statistics. That is something, a picture that I created from a colleague of mine. So you need to train these models, and you need, of course, to understand how these systems work. And it's not that easy often to build models and to have good results. So you have to train with a lot of data, because in this case, for example, of course, it's very similar, and it's maybe not that easy to differentiate between a human and an animal. And a human is an animal, but you know what I mean. This is something that I added just 2 hours ago. I read it at Spiegel Online. I don't know how many of you read about that, which is nice, a nice article. Maybe for afterwards, you can check this. It's interesting. So how neural networks, which is also kind of deep learning, which means there are systems that work similar, not really similar, but close to, or the idea is that it works like our brain. And these neural networks, which is more or less like a black box, there are no explicit programming rules, but it's a system that is trained with input, with pictures. And here, Google researchers created something interesting. They feed it a system with a lot of data, and the system was asked to understand the picture, but based on the data it got before. So the system knows maybe only about paintings, and then gets a photo, and this photo as an input, and is asked to understand something in this photo, and creates an output. And this is some examples of what these algorithms did, and it should just show, and please look it afterwards, it's too complicated to explain it now, how these systems start to create something new out of the data. So here we see this picture, and based on the system, what it knows from pictures, it was asked, what do you see in this picture? And that comes out, and which is very creative pictures, I would say. It's about, I think it's really interesting because normally you say these systems are not creative. And here you could start the discussion, is it creative? Especially when you see this picture here, for example, which was just a photo. And on this photo there was nothing about this dog or this part over there, but the system created that out of the original picture. The original ist, das Original ist hier tatsächlich kein klassisches Ölgemälde, sondern ein Foto von einem Mittelalterfestival. Darauf hat der Ritter weder einen Hundekopf auf dem Sattel, noch einen Handschuh in Tierform. Okay, back to topic. I said data, science, process, model. And now it's about the process, how we do such data projects. And normally these processes look like that. From IT world, you have I think the first lesson at university when you study computer science, or not the first, but very early, you learn about how these projects work, like waterfall model. You start with requirements, then you design the software, then you implement it, you verified it, and then you do the maintenance. And there were many of these processes of how an IT project should work like, and we created, as mentioned earlier, something like this, which should say, we start with the ideation phase at client side, really doing workshops and thinking with the client, what can we do with your data in combination with external data, but creating a business case, something that is valuable for a client and not just putting somewhere a huge system with only technology and then they don't know what to do with it, but really to start with the idea and then start to create the data pool. So to think, okay, now we have the business case, what do we need? What kind of data do we need to answer this question? And then we start to explore the data and try to find out, can we get something valuable out of this data? And will we answer the question that the client has based on data? And then we start maybe again there because we find out something and then we go back and then we ask something different, or we change the question and we found out something here which was not asked before, and then the client says, okay, much more interesting, so let's talk about that and maybe collect more data or different data. And if we did a kind of proof of concept, so we said, okay, we can answer this question, then it goes to automation, which means, for example, we do here exploration on data on my personal Mac with programming languages like Python, for example, just that you heard about that, or R, which are programming languages where you can be very efficient and do a very good hacking job. But then the system should go to live and should go to production mode. And here often then a technology switch happens. So what I do before on one system will now go to 5, 10, 100,000 nodes, a cluster of computers that is calculating the job, the analytics job that I before created just on my Mac, where I found out, okay, this is an algorithm that is useful to answer the question. So here it goes to automation, and then it's important to visualize the data and give the client access to that. And in the end, creating a kind of data product, something that is used and integrated to the processes on client side. So they have their business, they do their regular day-by-day job, and they now get a new system that needs to be integrated to the environment on their side. And here's Gartner, a cool vendor is meant, because Gartner, which is a company where they have many analysts. I don't know how many you heard about Gartner. They judge if you're doing a good job. And they said in 2013 that this process is great of how we do, from Unbelievable Machine, do these big data projects. Okay, this could be questions, initial questions. For example, sales from a company can ask, how can we segment our customers? They have many customers and they have also data about what they bought there. For example, when they work in business to business, also in B2B, in the B2B sector, they have maybe a lot of data about their customers and want to know which of the customers bought similar. Or for example, in e-commerce, why does my conversion rate raise fall? Which means in e-commerce you have a shop and you want to know how much was bought every day, and they want to know why do we have a peak or why did it go down when you have, for example, shops that we use every day. Of course, they want to know if they sell less, why, what is the reason? And this case that I mentioned, how can we predict machine breakdowns, for example? So several industries, different questions, there can be many more, but here in this case, really business questions. Then we start to create this data pool. And just to see some technical stuff, we, for example, have, we could use, for example, server logs. When you have an e-commerce shop, this servers where the e-commerce shop is running create log files. And log files is just a row in a text file. And in this row, you see what was clicked on the website. And this data you can, for example, use to know about when did someone buy something on the shop, which is the first step to know about the conversion rate or to know about when did people buy on the shop. And later add more and more data, like, for example, weather data or any data which can have an influence to the fact that someone bought or that less people bought than in history. And we, in this phase, we get this data and put it somewhere, create a sample of the data because we don't need everything, and put it to technology, to databases. In this case, it was a MongoDB, which is a special kind of database. You don't need to know about that. But you have different data, and you put it somewhere in a database that you can use, where you can run your algorithms, and then you start to explore the data. Okay, so we do a lot of exploration with different algorithms, with different databases, everything that we need. And this can be also, for example, a plot that shows me, for example, which customers bought similar in the past. So this is, each dot here is a customer, and I see, are there clusters, are there segments of customers that bought similar? Just to give you some inspiration here, I don't know how many of you did some statistics. This is classical statistical analysis box plot that shows you, are there outliers in my data? Okay, so we try to understand the data and do many iterations to better understand the data based on the questions that was asked before. And we work with tools like that. So here you can write code in the browser and you directly get the plots. And you can understand the data. And you can show the results also directly to the client, what we do. So we program something and we do the analytics, but we create plots that the client can understand to see, do we come closer to answer the question that was asked initially. And that is something, that is a programming language, Python, they mentioned before. There are many others, and of course, it's a technology thing. So the data, there are tools with GUIs that you can use, but in the end, you need to have some knowledge about programming. Which can be very easy because you just need to start. And it can be very funny and very interesting, really, trust me. Okay. So we did exploration and we want to get it into automation. And what could this automation mean? For example, a custom machine learning as a service solution. So we put the algorithms that where we find out they are useful, for example, for the stock market prediction. We found the best algorithm to predict the stock market for the next day, the prices or the value. And then this logic we use and put it into a box. Because in the end, the client is not really interested in the algorithms. They just want to have the results. So we put it into a box and put something in front of that, which is kind of interface. How many of you heard about an API, an application programming interface? Okay, I recognize I'm maybe a bit too technical. But an API is just an interface that you can use to plug to a system. For example, when I use Google, I use it in a browser. And I do a search. The same thing I can do programmatically by connecting to the Google interface. So I can write a few lines of code, and it will ask Google, for example, search for Humboldt Universität, and then I get the results back and can use it. that we are doing that every day with an interface, but you can use it also programmatically. So in the end, you have a black box with your algorithms that can be wherever, for example, in our data center, and then you have an interface and someone can do something with it. So the client can use the algorithms that are here, for example, sending raw data here, then they are calculated and they get the results back and they can do something with it. And I think I will jump this slide. But of course, it's very important and very strongly connected to the topic. It's infrastructure. So as said, in the end, it's technology and it needs to be computing. There need to be computing power that can be dedicated servers, for example, or cloud infrastructure. And we don't want to talk now about what a cloud is. But in the end, clients want more or less everything as a service. So they don't want to know what is going on beyond and how these algorithms work, and they just want to use it. How we, for example, want to use an email account, but we don't want to know where the server is. Maybe some of you want to know where the server is. But in the end, we want to use it as easy as possible. And one example of a great machine learning as a service is Genie. You can check that out afterwards. Genie is an API that I can use, and I can use it with my browser. I can ask Genie, for example, via my browser, Genie, what's machine learning? And I get a result that I could now use for different purposes. For example, calculate something on that, or analyzing the results. And because Genie gives me an answer and says, you are a very geeky person. Or for example, what is an API? And Genie gives me back the Wikipedia article about an API. So some of you should read that afterwards also. And for example, how do you work? And Genie says, I read what you say, and then I compose the best reply I can think of. So something like Siri that we are using, or not all of you are using, but it's open source, and we can use it. And I could simply use this API, and I don't need to know how it is working and where it is calculating, but I have an interface. I can give an input, a question, calculation is done, and I get back a result, in this case an answer. In this case I asked, because I did that also for a university in Potsdam, was ist die Universität Potsdam, and then I get back the address at least, which is also great. Okay, APIs, what is it? I told you, but here, for example, this is how the Google service, the APIs does look like. Too much details. This is just 11 lines of code that I wrote to use the Google search engine, and I searched for Uni Potsdam. And then on my console, on my terminal, on my Mac, I get the results. That is what I normally get when I use the graphical interface from Google. But it's just 11 lines of code, and it's not complicated. And you ask for Uni Potsdam and get all the search results for that. These are some services for machine learning as a service, just that you have heard about that. There are many, many services where we now can use this artificial intelligence logic like a black box. We put something in, something is calculated, and we get something back. Maybe you can do some research. Maybe you heard about IBM Watson, which is one very famous system. Okay, visualization could look like that. For example, doing graph analysis, having a dashboard system on my mobile device that the client, for example, can analyze the data very easily, and not only having a programming interface because they don't know how to use it. They want to have some charts that give them some information about the data that they are interested in. And interfaces, categories can be, for example, for the management, they want to have bar charts, or I don't know. And the experts on the client side, maybe there are some IT, some technical guys from business intelligence analysts. They want to be able still to analyze data by itself. That should be also often very often possible, that they still have the power to use the data, not only getting such a black box, or really you have APIs and you provide the client APIs so that they can programmatically get output from the system that we created. Such a dashboard could look like that. So for example, that the client can see how their product performed in the last month and to understand if they are selling great. And when it goes to production, it means for us that at the Unbelievable Machine Company, as we do this whole process of from idea to cable, that different people from different departments work together. So I, as a data scientist, work together with data engineers and with system engineers. So to be able to tackle such a complex task of starting with an idea to a final product that can provide something like this. So, for example, so a manager can log in to the browser with email address and password and gets all the information, all the calculations of the data that they are interested in. And beyond that, of course, there is a system that provides all that. So I showed you some cases. I showed you some questions that someone can ask, and someone who is interested in data on the client side across industries. I talked about sales. I talked about industry. I talked about e-commerce. So there are many companies and different departments who are interested in getting knowledge out of data, and all of that, of course, I'm only able to give you some inspiration and not fully explain you how such big data science projects work. Of course, I can do that afterwards, but maybe you have now some information and you have a basic idea of how that looks like and what you are doing and what this process looks like. But if you, one thing please that you can keep in mind, if you want to forget everything else, these data science projects, of course, it's a technological task, but the idea, the business case in the beginning is very important. You need to know what you want to know from the data. And the other thing is that data science is a team sport. So it's not just one person or who can solve this task. There are many different fields that it touches, like programming, statistics, mathematics, business, machine learning, big data, and much more. And I'm sure it could be also interesting for all of you working in this field. And here you see different people who have some, not all of them know everything in these fields, but in the end it's a goal to bring people together who are good in something. So someone knows more about statistics, someone is more a business person, and to do these projects, you need to have many different people with different knowledge and different fields of expertise. That's it.